Hello everyone. Transformations. The transformations are not that complicated in this unit. They're literally based on the transformations of quadratic and cubic functions that you have been doing before already. So this is pretty much just a review. The only difference will be the quartic function. However, it has the shape exactly like the quadratic function. So the transformations applied to it will be very similar to the transformations of the quadratic function. So let's look at the first example. Just as a refresher, we're going to look at the quadratic functions and the transformations that have been applied to this function. So we have f of x equals 2x minus 4 squared plus 5. So as in any other transformations of functions, you have a value, which is 2. It's now our vertical stretch or compression. In this case, we're vertically stretching because a is greater than 1. We are moving to the right because of the negative sign, 4, and we are going up 5 units because of the 5. That's a vertical translation. Value in this case is 1 beside the x. So polynomial functions are power functions, and their exponents can only be integers. They can only be positive. In the equation of the form y equals a k x minus z to the power of n plus c, a is the vertical stretch or compression, k is the horizontal stretch or compression by a factor of 1 over k, d is the horizontal translation, left or right, and you're going to the right if this is negative, and c is the vertical translation, up or down. If it's positive, it's up. If it's negative, it's going down. Let's look at some examples. F of x equals x cubed. It's just a basic function. Cubic function that will look just like that. Not transformed. It will go from quadrant 3 to quadrant 1. It goes through the origin. It does go through the origin. I apologize for my graphing. Okay, because we have a negative here, this negative represents the a value, which is responsible for reflection. We are reflecting over the y-axis. Since we're working with an odd function, our a value becomes our k value, in this case c. There is no difference between this one and that one because you will still get a negative. So you're not reflecting over the x-axis because it will make no difference for us. You're reflecting over the y-axis. For any odd function, when a is negative, you're reflecting over the y-axis. Okay. Next one, we added 1. This 1 is responsible for the horizontal translation. It's plus, so we're moving to the left. Our function is not going through the origin anymore. It's going through negative 1. So I'm at negative 1 here, and that's now where I'm going to cross the x-axis. Okay. Now, the next one, I have 2x cubed minus 1. I am vertically stretched. That means that I have to multiply my y values by 2. Not my x values, but y values by 2. and go down 1. Go down 1 on the y-axis. It's a vertical translation. My next example has a vertical compression of 1/4. So I'm multiplying my y values by negative 1/4. I'll be reflected and vertically compressed. My k value is 1. I'm moving to the right 3 units, and I'm moving up 0.5 or 1/2. So technically my graph should look something like that. I'm compressed, so I'll be flatter. I'm moving to the right 3, so I'll be here and here. I'm moving up 0.5. So this is 0.5. So this is my 1/2. This is 3. And I'm going this way from left to right. 1/4. I'll be compressed, so I will look sort of a little bit flat. Like that. It won't be as stretched. It will be fairly compressed graph. One thing that you will need to remember is to find your y-intercept in this case. See that? Y-intercept. Because it's important where you cross the y-axis. I don't know where I am, but I have to sub in where x equals 0. What is my y? So x 0 minus 3, negative 3 cubed times negative 1/4 plus 1/2. This is where my y-intercept is going to be. Okay. X to the power of 4, which is a quartic function, looks very similar to a quadratic function, only a little bit wider here on the curves. And the idea will be the same as if you were transforming a quadratic function that we're talking about. You'll be reflected over the x-axis, okay, because it will change. So here it's like here it stays negative because you're not in brackets. Here it is positive because you are in brackets. You'll be reflected in this case over the x, moving 2 to the right because of the negative. And here you are vertically compressed by 1/2. You are reflected over the x-axis and you're moving up 3 units. Here k value is factored out. You're horizontally compressed 1/2. You're moving to the left 3 units. Let's look at the graphs that the calculator produced for us. Okay, so we can see that in the last one, right, you were horizontally compressed and you moved 3 to the left, and then for the one before that, you are reflected over the x-axis. You're reflected over the x-axis and you moved up 3. Okay. Alright, let's move on. On your own, determine the equation of the following transformed function. So the parent function would be Now I want you to pause the video and try and do the transformations on your own. Once you're finished, play the video again and compare to what you got. Alright, here we are. So the parent function is a cubic function, x cubed. F of x equals x cubed. Transformations that were applied. We shifted it right 5 units up. Then what we did we do anything else? Nope, there was nothing else done to the function. We simply shifted it plus 5. Vertical translation. What is our domain? All real numbers. What is our range? Same thing. And behavior. As x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. X and y intercepts. Y-intercept is at 5. X-intercept is at negative 1.8. But you will need to do that precisely using equation when you're given one. If you do not have an equation, do it from the graph or set up a table of values. And when you do when you apply your transformations to the points, use the table of values to figure out what your new x and y intercepts are. Try to describe the transformations that have been applied to the following function. Sketch it. Do not forget, whenever you do not have brackets and x has a coefficient that's not 1, you have to factor out the k-value. Here, the coefficient beside the x is 1/2. You need to factor it out before you can proceed with sketching the graph and applying the transformations. And here is what your graph should look like. Okay, hope this video is helpful and you are now okay with applying the transformations to cubic and quadratic functions. Please practice a little bit more and get ready for tomorrow's quiz. We will do another practice question in the beginning of the class tomorrow morning and then do the quiz after. Okay? Hope everybody's fine and see you soon.